As I was working on different flavors of EVM interpreters built in the EVM, I quickly realized that debugging an EVM interpreter with current tools is more cumbersome than it needs to be. Debugging anything that has a recursive process or is based on loops is like a Sisyphean task because you cannot just jump to the first opcode from a loop at the 10th iteration. For a long time I used the Remix IDE debugger, which falls short at this task. So I improved the entire EVM debugging pipeline to accommodate for this need. And what you see here are several independent components that can communicate with one another. Everything is built with Mark's Factory and Taylor. This left part is the Cometh EVM debugger. And the right part is the Ethereum IDE, which allows us to compile, deploy, and interact with Ethereum contracts and work with everything from Solidity and Yule code and macro assembly to assembly and bytecode. Both were presented in previous videos, and now you will see them working together. Any mark created with Mark's Factory can now communicate with one another to create a powerful ecosystem. Here I have a simple version of an EVM interpreter written in our macro assembly language. This is transpiled to EVM assembly, which is then transformed to bytecode. We deploy this bytecode to a test network. And now we want to interpret the bytecode and call data for a contract, which I am going to fill in this raw call data input. To use the debugger for this transaction, we select Debug All or Debug Once and click on Run. And we get all the opcode steps. These are the opcodes in the execution order, so ordered by step index. We can also see the point in code index. And if we select an execution step in the debugger, like this push 0160, we can see the exact assembly code line that produced this opcode. And it works both ways. We can see the mstore opcode here, and its side effects in memory are highlighted here in blue. Now let's go to the main loop of our interpreter at tag 2, which is a jump destination. This is where we read each opcode from the bytecode that we fed to our interpreter here. So this loop can be passed through thousands of times each time an instruction is executed. So let's click on the line gutter here. And the debugger has jumped to the same position in the code, which is 56. And the 31st execution step. We can now select at what loop count or loop iteration we want to go from here. So point in code 56, iteration 1. And we are now at point in code 56, step 77. Let's see iteration 10. And we are now at point in code 56, step 368. So it is the 10th iteration of this loop, which means the 10th bytecode instruction from our interpreted bytecode. And we can go on to the 20th iteration at step 727 and so on. And we can start debugging from here. Instead of blindly going through the opcodes by pure gut estimation. You will not see this feature in other similar products at this time. The Cometh Debugger, Ethereum IDE, and Mark's Factory are built by volunteers for volunteers. Details in the description.